Philip is going to give us a great talk now, PLC for home automation and how to make it a honeypot. Without further ado, please come in a little silently, turn off your phones, and enjoy.
Hi. Hi. Works? Okay, thank you. Okay, first of all, I would like to thank B-Sides for having me here. Oops, it's echoing. And I would like to thank my mentor, Scott Irvin from Productivity. They have their booth just outside, so please check it out. And thanks for everyone who's sitting in this room. Okay, so today I'm going to talk about PLC for home automation and how to make it like a honeypot. It may not be what you have imagined. It's not about how to crack a PLC, not about how to break it, because Trend Micro is not playing red team. So it's about having fun. Okay, so this is how you might imagine about home automation. Like an open hub project with Raspberry Pi, some neat modules that you can purchase on Seeds or the online retail stores. And you put something like your mailbox checker, your washing machine, to monitor the temperature, humidity of your house. But just a friend of mine had this idea of making it a little bit more robust. Like using an industrial level PLC, you can have something that works for 20 years. You don't even have to upgrade the firmware, and that's part of the problem. Well, so you just install and forget, and it will run forever. And nowadays, they even have some user interfaces like IFTTT, very beautiful HMI. So you don't even need to tweak on a Raspberry Pi. The interface is like this. So if something, then something. And you still have to understand a little bit how PLC works. For example, you have to configure a timer that sends heartbeat. Otherwise, if someone just DDoS your PLC, you're dead. So PLC is just not like a modern computer. It's a little bit weak. I mean, the CPU is weak. So if you DDoS it, it stops to work, and everything's gone, and there's no security anymore. So this is how my friend's house is designed. As you enter the house, there's an IR infrared sensor. As the sensor is activated, within 1 minute, you have to push the keyless key to unarm this rolling code remote controller. Otherwise, there's a siren with 100 dB would buzz very loud to alert everyone, to scare your shit out. Sorry for dirty words. Okay, and then there's a reed switch on the main door, so you cannot just come in and try to lockpick the door. It doesn't work. It will. The siren will buzz. So it's how the buzz looks like. And he's a freak. He has designed all this circuits like a Modbus TCP GPRS with GPRS module. So if anybody enters his house, there's a SMS sent to his cell phone. And there's an external module that talks RS-485. So he has additional digital ins. And there are backup powers. It's a double-looped powered circuit. So when anything fails on the main circuit, there's a backup power powered by UPS. And there's alarm, 16 DIs that he's just having fun. And he even kind of tweaked a bit and used a heater and a backup alarm. So the thing is, he has to configure a timer to send heartbeat to this backup alarm here. If there's no heartbeat within 3 minutes, there's another SMS will be sent to his mobile phone. So he knows something's wrong. And just some peripherals, patrol helicopter, for example, that's just for fun. So here's how things are wired. Well, I will leave it to you because you can download all the slides and all the programs in this talk on GitHub. Everything's open sourced, so you can check it out on yourself, and you can probably try to implement that with your Raspberry Pi. That's how I did it here. No worries. My pleasure to share everything. Yeah. Okay, so here's how to break into the house. You might try to trigger the IR sensor without key lock, boom. You open the door without the key lock, booms. You cut up AC power, and there's UPS, and you want to short circuit because it's triggered by, it's low triggered, so you might want to ground something, maybe. Or you can hack into a VPN, like send him some pornography and get his IP address, hack into his home router. Sorry, that's not what I want to talk about today. You can do that, I'm pretty sure. And that's what we do every month. So I know you can do that. But the thing is, you should not stop sending the heartbeat. You have to be very careful. Otherwise, he knows it. Yep. So the only thing that might break this design is a failed power rail on both powers. And it happened once. So that's Murphy's law. What can be wrong will be wrong. So you cannot just smash and grab because he has he's really a paranoid freak. He has his wire mesh class installed. So maybe the robbers want to just go to next door. Sorry for his neighbor, but yeah, it's how it works. Or you might want to break this rolling code thing with a, that comes with a really good PRNG. So you might want to follow Sam Kamker's talk in DEF CON 23, that's last year. You just record this wireless radio signal and play back. That might work. I haven't tried it. Or you just use ethylene heater to break his main door. And yeah, that works very well. So what's next? Now we have a armed house. We have a PLC that talks Modbus on port 502, like everybody knows. So we can make it a first level honeypot. What's a first level honeypot? It just copies the readings out of this PLC and use some use a open source library that runs on Raspberry Pi to try to expose itself onto the internet so that someone might find your PLC through Shodan. If you went to the session this afternoon, there's a door key. So it scans Shodan for exposed PLCs. So maybe the bad guys might be interested by the PLC exposed on the internet, and but it's a fake one. You just copy the real-time value. So it's updated every minute. You open a door, something changed to 1. You close the door, something changed to 0. So it looks like really authentic. So the bad guy might think this is a real thing, and he might want to change something that you can log. So this is the architecture. So of course, Smith K wants to change some coils or some holding registers and feel happy. And I have even made a web interface, a very simple web interface. I cannot call it HMI because it's just Flask. Yeah, so he might be caught. Smith K, if everybody knows, that's out of Kafka's novel. Okay, and we can make it the second level honeypot just by adding a little bit imagination. It's a self-adaptive honeypot. For example, some state changes in this ground truth PLC, and you add some delays to procrastinate this change. Or, for example, something changes in the holding register, you just don't make a copy, a direct copy. You put it on some polynomial function to make it match the value slowly to make it look like a real thing. And the good thing is that you can change the parameters and deploy this honeypot worldwide out of the same ground truth. So eventually, you can have 10 honeypots, 100 honeypots that act differently. Yep. So, and yeah, Python is really a simple script language that's really powerful. You can also bind a pseudo pump onto it. And this is the architecture, just some fuzzy function. This is how it looks like. I have a live demo, but unfortunately, I don't have a PLC at hand. Limited by budget. There's only one PLC, and I cannot leave my friend's house unarmed. So this is a very vague copy. I apologize for it. Okay, so this CO9 is a heartbeat pin. You can see it change every second. And if someone just took some, flip the switch, you can see something changed here. Yeah, or you can see that readings of this holding register changes little by little. So that's how it works. Or just wire this DI with some coil, and use that coil to enable a pseudo pump or a real pump if you want to make fun of yourself. Yeah. So things like that. So recap of what's in this talk. So we have a PLC securely fastened we have a house securely fastened by a PLC with a double loop circuit, and we can make it a simple level 1 honeypot, and we can make it a little bit complicated second level honeypot, and we can add some simulated pump to the circuit very easily. And you have the code here. Just download it, fork it, have fun, and if you want, send me some PR. I will be very grateful. Yeah, so that's it. You can add me on Twitter, or fork the code, or just write me. I work for Trend Micro, and thanks to Trend Micro for flying me here. And here's some, sorry, I know I should not do live demo because, you see, live demo never works. Exception, exception. Yeah. So, sorry. Bear me for a second. Yep, you see here, the coil 9 is a heartbeat pin. It changes every second. And I have made a Raspberry Pi that monitors the heartbeat. If anything's wrong, if there's no heartbeat within 3 seconds, a simplified version of the original one, a red light turns on. So that's just an imitate, a very bad imitate of the original thing. And yeah, this is how you do things. If you happen to fork it, you see the value dumped, and something's listening. And oh, OK. So I know what's going on. It's something mysterious with Raspberry Pi. Just ifconfig for 2 more network, and things should be going. OK, level 1, level 2, and HMI. It's not really HMI. I just called HMI for nothing. OK, so this is the underlying one. Oh, sorry, reloading. Yeah. Yeah, you should not do a live demo.
Awesome. Ready for questions?
Yeah, any questions?
Anybody?
To start experimenting with the PLCs, would you recommend any particular families or types or manufacturers or protocols or anything like that?
Actually, we're using ICP DAS just because it's very cheap. It's like $200 or $400 if you buy it at stock price. But I believe you can find something cheaper on eBay. Please don't try those Siemens ones. It's super hardcore, much more expensive. But it works. Thank you. Yes, please?
Is there any interactivity back to the attacker, or is it just, data goes in and dies and gets logged? Are they getting any feedback back to, to think that they're interacting with an actual PLC, I guess?
Well, you can do that, but Actually, I haven't done this until 1 month ago, so there's no field experiment. Sorry for that. I will try to, and maybe keep you updated on Twitter. Yes, please?
Do you have any recordings of sessions of people in the machine, in the honeypot?
Yes. Let's see if it works. So, B-sides. So thank you for the question. I almost forgot this thing. So let's see, swap coil. Okay. You see, someone has set the values. And you can put this log onto Elasticsearch or any database that you want. So record it. Yes?
Anybody else have questions? Going once, going twice. All right.
Sold. Sorry.
Sold. Thank you, Philip.